Hello, good evening, everyone. Can you people hear me?
Good evening, sir.
Okay.
Okay, so let us start. Last day we were discussing problems on total number of selections. Okay, today let us continue. Can you people see my screen? This was the last thing we had done. Hello, can everyone see my screen? Hello.
Yes, sir.
Panini Rakti Manandit, can you people see my screen?
Yes, sir.
Okay. Okay, then let us continue. Just give me 1 minute. Okay. Okay, so let us continue, everyone. Today we are going to discuss summation of numbers. Okay. So let us start. Summation of numbers. Okay. For example, find the sum of all numbers. Find the sum of all numbers. Okay. Find the sum of all numbers greater than 10,000. Count by the digits. Count by the digits. Can you hear me?
Yes, sir. Good evening, sir.
13579. No digit being repeated. No digit being repeated. Okay. No digit being repeated. Okay. Find the sum of all numbers greater than 10,000. Count by the digits 13579. No digit being repeated. For example. So everyone, let us start. Okay. Method 1. Okay. First of all, tell me what is the total number of numbers found by 13579 greater than 10,000? Using all the digits at most once. Only once you have to use. Tell me. What is the number of numbers?
5 factorial.
5 factorial? Right. Total number of numbers will be equal to 5 factorial, which is equal to 120. Right. Memel, are you getting? Tell me.
Yes, sir.
So, Memel, did you go through the recording?
No, sir. I didn't get time.
Didn't get time. Then how will you understand?
Sir, I'm trying to understand now.
Okay. Go through it at home properly.
Yes, sir.
Total number of numbers will be equal to 5 factorial, which is 120. In this 120 numbers, one will appear. One will appear in the units place how many times? Tell me.
4 factorial times.
24 times? Right. 3 will appear in the units place. So how many times? 24 times. 5 will also appear in the units place 24 times. Okay. So what is the sum of all the units place? Tell me. What will be the contribution? 1, 1, 1, 1, dot, 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 dots, then 3, 3, dot, 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 then 5, 5, dot, 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 7, and somewhere 9. What will be the contribution in the units place? Tell me. 24 into 1 plus 3 plus 5 plus 7 plus 9. Right, tell me everyone. Similarly, you will get the tens place. Right, in the tens place also, you get the same total. 24 into 1 plus 3 plus 5 plus 7 plus 9. Okay. So can I say the sum of all the numbers? Hence, the sum will be equal to 24 into 5, 24 into 1 plus 3 plus 5 plus 7 plus 9. Okay. 1 plus 3 plus 5 plus 7 plus 9 multiplied by. Okay. For the units place, it will be 10 to the power 0. For the tens place, it will be 10 to the power 1. It will be multiplied by 10 to the power 1. Yes or no? Tell me everyone. Tell me. Emil, Shamita, Ratil, Anandit, or many other people getting? Tell me. You have to add 10 to the power 1.
Yes, sir.
Actually, wait a minute. You will understand more. Multiplied by 10 to the power 0 for the units place plus 24 into this whole thing. For the tens place, it will be 10 to the power 1. Yes or no?
Yes, sir.
Yes, sir.
Ratil and Anandit, are you people getting?
Yes, sir.
Okay. Then again plus 24 into the same thing. This time multiplied by 10 square. Dot 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 up to 10 to the power. For 10,000 it will be up to 10 to the power
4.
4. Multiplied by 10 to the power 4. Okay. So finally what are we getting? 24 into 25 into 10 to the power 4 plus 10 cube plus 10 square plus 10 to the power 1 plus 10 to the power 0. Is it clear? Tell me. This will be your final answer. That part. See, once you are adding, one is there how many times? 24 times. 3 is there how many times? 24 times. 5 is there how many times? 24 times. 7 is there how many times? 24 times. 9 is there 24 times. Is it clear? Okay. Yes, good evening, Devang. Can you hear me?
Good evening, sir.
Yes. Devang, I'm doing summation of numbers. Okay. Like, read the question once again. Find the sum of all the numbers greater than 10,000 formed by the digits 1, 2, 1, 3, 5, 7, 9. No digit being repeated. Okay. None of the digits has to repeat. Okay. This is one of the method. Total number of numbers will be 5 factorial 120. 1 will appear in the unit space 24 times. 3 will appear 24 times. 5 will appear 24 times. Okay. 7 will appear 24 times. 9 will appear 24 times. Right. Okay.
Yes, sir.
So 1, 24 times. 3, 24 times. 5, 24 times. So the units rate, contribution by the units rate will be how much? Contribution
24 into sum of 1 plus 3 plus 5 plus 7 plus 9.
1 plus 3 plus 5 plus 7 plus 9. Right. This will be the contribution by the units place. Okay. Same with tens place, same with hundreds place, same with thousands place, and same with 10,000 place. Right. So see, so the sum will be equal to 24 into 1 plus 3 plus 5 plus 7 plus 9 into 10 to the power 0 for units place, into 10 to the power 1 for tens place, into 10 square for hundreds place, into 10 cube for thousand place, into 10 to the power 4 for 10,000 place. Is it clear? So finally, you are going to get this expression, okay, which will be equal to 24 into 25 into 5 ones. Okay. I hope this is clear to everyone. This will give us 600 into 5 ones. Okay. So I hope you people have understood. Okay. This is the number of times the digit will appear in a particular place. In a particular place. This will be the sum of all the digits. This will be multiplied by 10 to the power 4 plus 10 cube plus 10 square plus 10 to the power 1 plus 10 to the power 0. Is it clear? How you have to write down the sum of all the numbers? This will give
Yes,
us 5 sixes and 2 zeros. Okay. I hope you people have understood the pattern. Method 2. Method 2, I generally don't use, but again, let's see. Okay. This you can do it by simple addition. Okay. This is, let us say, column 1. Okay. Column 2, column 3, column 4, and column 5. Okay. Acha. So it is like sum of all the 120 numbers. Okay. The way you have done addition in class 2, 3. Okay. Right. You people have done addition, subtraction, class 2, 3. So tell me, what is the sum of all the numbers in column 5? Tell me. What is the sum of all the numbers in column 5? Tell me. Tell me, what is the sum of all the numbers in one column?
600.
600. So 0 over here, 60 carry over. Again, tell me, what will be the sum of all the numbers? 60, 600 plus 60, 660. So 0 over here, 66 carry over. Again, tell me, what is the sum? 600 plus 66. So 6 over here, 66 carry over. Then again, what is the sum over here? 600, 666 over here, 6. So 66 carry over. Tell me, have you people understood this method also? It's a simple addition.
So there should be another 6.
Another 6, let's see. Ah, yes, another 6. Wait a minute. Another 6, yes. Tell me, is it clear to everyone this method also? Ratin, Anandit, Samita, Devang, is it clear? Email, is it clear?
Yes, sir, but as I didn't see the video of the last previous class, so I couldn't
This
understand.
this concept has nothing to do with the things I have done in the last class. This is a
Okay.
totally a new concept. Summation of numbers. Last class I have done total number of selections. Okay,
Okay, sir. Okay,
and
sir.
circular permutation. Tell me if you have not understood these two methods. Let me know. I'll explain. Tell me.
So now your screen sharing is off.
No, it is on only. You are unable to see the screen.
Yes, sir.
Are you able to see my screen or not? Tell me.
So now it is black.
Is it? I mean, others can see the screen.
Yes,
Only.
sir.
Yes, sir.
Okay. So, Mimir, I think you have to rejoin. Okay.
Sir, I'm rejoining.
Okay. Okay. Devang, you have understood this method?
Yes,
Tell
sir.
me. Okay. Next. Method 3. Another method. So, generally, I'll tell you to use method 3. Okay. I mean, mostly you use method 1 only. I mostly use method 1, but method 3 you use when the digits are in AP.
So now it is coming.
Okay. When the digits are in AP. Okay. So tell me the smallest number. count by these 5 numbers. Tell me. Tell me the smallest number.
1, 3, 5, 7, 9.
Tell me the next. Tell me the second number in the ascending order.
1, 3, 5, 9, 7.
Tell me, Shamita, are you getting? Shamita, Raktim, Anandit.
Yes, sir.
Plus dot 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 dot. Okay. Plus 61st number. I have divided the I have divided all the 120 numbers into two parts. 60 plus 60. The first 60 numbers I'm going to write down in the first row. Next 60 numbers I'm going to write down in the second row. Okay. Next over here you will get 61st term. Okay. Plus 67 terms. Understood everyone how I'm arranging? I'm arranging it like this. In this manner. Plus 62nd term. Okay, plus dot 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 dot. Tell me the last number. Tell me the highest of them.
9, 7, 5, 3, 1.
97531. Tell me, Raktim, are you getting? It's not going above your head, right?
Yes, sir.
Okay. Anandit, are you getting this?
Yes, sir.
So Anandit, tell me the second last number. What will be the second last number? Anandit? Anandit, what will be the second last number? Hello, Anandit.
97351.
Samita, why are you making mistake in this one? Think about it.
9, 7, 5, 1, 3.
97513, right? It's like arranging in ascending descending order.
Yes, sir. Yes,
Is it clear, Shamita? Tell me.
yes, sir.
Now what we are going to do is I'm going to add. Tell me the addition. Addition of the first column. Tell me, what is the addition? Only one person is replying. Others are not getting. Tell me. Okay. Next, tell me, what is the addition in the second column?
Sir, same.
Okay, so that means every particular column will give us the same return. Okay. So tell me, how many times I have added? 5 ones and 1 0. How many times are there?
60 times.
60 times. What would you get? 6666600. Tell me, which method you liked more? Method 1, 2, or 3? Which method you liked more? But I would suggest use method 1 more. Okay, method 3 you use when the terms are in AP. Okay. So everyone, let us do some problems. Anyone having any doubt? Tell me, Samita, Raktim,
No, sir.
Anandit, Omini,
No, sir.
Nenel, Devang.
No, sir.
Okay, so
Most
first question for today, right there on your screen, very soon. Okay, start solving. Okay, you can give the answer in terms of expression also. No need to simplify completely. Okay, solve. Once you've done it, send quickly. Solve these two questions quickly. You people are able to recognize the second question, right? Hello, everyone. I'm audible.
Yes,
Yes,
sir.
yes.
Okay. Should we start first one? Tell me, everyone. Should I start the first one?
Sir, please read.
Okay. Okay. So Nini has sent. Let's see. Nini, you are making a slight mistake. You are unable to understand what digits are being used. You see, 02468. You are making some mistake. Yes. Ratim, you are also making the same mistake. Remember, zero is also there. Should I start?
Sir, almost done. Please read.
Almost done. Okay.
Sir, I've sent.
I received it. Yes. Devant, you are absolutely correct. Anandit, check your answer again. Okay, let me start. So first of all, you find out the total number of
Sir, I
men.
have sent.
Okay, Shwamita, I haven't received yours yet.
Sir, did you receive it?
I have received yours, but that is not the correct answer.
Sir, in the third question, is it written at least once, at most once?
The third question. Actually, Shwamita, your answer is correct only. Okay.
Okay, sir.
In the third question, find the what?
Yes, sir. I was
At
asking, is
most,
it
at most,
at
at most,
most
at
or at
most,
least?
at most, at most.
Okay, sir.
Okay. So Andini, Raktim, Mehmel, Anandit, pay attention. Over here, we need to find out the sum of all the numbers greater than 10,000 found by the digits 02468 such that no digit is being repeated. So you must have done total sum. You must have done total sum. Total sum will be equal to each digit will appear 24 times in each place multiplied by their sum. Okay, multiplied by 1, 1, 1, 1, 1. Right. This will be the total sum. But over here, there is a problem. Can you people identify? Shwamita, Anandit, Raktim,
Yes, sir.
and tell me what
So it should be greater than 10,000.
exactly. So zero cannot be in the first place, right?
Yes, sir.
Tell me. So let us find out the sum when zero is in the first place. When zero is in the first place, okay, case two, this is case one. Okay, when zero is in first place, then what will happen? You fix zero in the first place. Now each digit will appear. Each digit will appear in each place. How many times? Tell me. Each digit will appear in each place how many times? What will be the total number of four-digit numbers now? Tell me.
3 factorial times.
3 factorial times. Right, tell me. Raktim, Anandit. Nemil, Shamita, did you understand? Okay,
Yes, sir.
this part. So, Raktim, see, it will be a 4-digit number now, right? If 0 is in the first place, we need to think about only these 4 digits. Now, in these 4 digits, what will be the total number of 4-digit numbers? Tell me. What is the total number of 4-digit numbers?
24.
Is equal to 24. And each digit will appear how many times?
6.
Tell me. 6 times. 24 by 4, na? Unitary method. Forgotten unitary method. Is it clear? Tell me.
Yes, now it is.
So what is the sum? So sum will be equal to 3 factorial into 0 plus into 2 plus 4 plus 6 plus 8. Okay. Multiplied by 4 ones. Is it clear? Tell me. 3 factorial into 2 plus 4 plus 6 plus 8 into 4 ones. This will give us how much? Okay, whatever it is, no problem. So therefore, the final sum will be equal to 4 factorial into 20 into 5 ones minus 3 factorial into 20 into 4 ones. Okay. Is it clear to everyone? Okay. Tell me, Amini, is it clear?
Yes.
Okay. Okay, solve number 2 and 3.
Sir, can we only give the expression
Only the expressions are required.
because the calculations are quite big?
Only the expressions are required. How many after 12 into 6 in the first line? What you wrote? 12 into 6 into how many ones?
Uh, sorry,
In the
sir. It
first.
should be four ones.
Okay, okay. It's correct. It's
Mm,
correct.
okay.
Yes. Devang, your answer is correct. Ratim, check your answer again. Again, Ratim sees zero is present. It's a similar type of problem. Why are you making a mistake? You didn't understand number one. Tell me.
Yes, sir.
Similar type of problem, right? Number two and one. What is the difference? See?
Sir, I solved three by mistake.
Oh, yes, all three. Wait, I'm checking this.
By mistake, I solved it.
Okay, no problem. Okay, Shomita, there is a slight mistake in number two. Okay, Raktim, if this is the answer of number three is correct. Okay. Okay, Anandit, you didn't understand question number one. I mean, the solution. Did you understand?
Yes.
So, if you have understood in number one properly, why are you making mistake in number two? They are same only. Check it again. Check number two. Yes, Shomita, number three is correct. Hello, Memel. Are you solving?
Yes, sir.
Then, friend, if you understood number one, you should be able to solve number two. Yes, Raktim, your answer is correct. Okay, Memel, pay attention. Memel and Anandit, pay attention. We need to find out sum of all the numbers greater than 10,000 formed by the digits 0, 1, 2, 4, 5. So, see, question number one. Okay, Memel, check your answer again. Okay, Memel, pay attention. Number two, Memel and Anandit. Question number one says we need to find out the sum of all the numbers above 10,000 formed by the digits 0, 2, 4, 6, 8. Okay, but we need to find out the sum of all the numbers in the second one is greater than 10,000 formed by the digits 0, 1, 2, 4, 5. Okay, so what can we do? See solution number two. The required sum will be equal to 24 into what is the sum? 0 plus 1 plus 2 plus 4 plus 5 multiplied by 5 ones. And from here, we need to subtract those numbers when 0 is in the first place. So minus 3 factorial into 0 plus 1 plus 2 plus 4 plus 5 multiplied by 4 ones. Okay, this will be your answer. Tell me. No, Anandit, you are making a mistake. For the next one, it should be four ones because it is a four-digit number now. Tell me, Anandit, did you understand or should I
Yes, sir. Now
explain?
I understood.
And Mimel, did you understand it properly? If you have not understood, tell me, I'll explain again.
So, like in the last I need to subtract both. I just sent you the two given, I mean the expressions.
Let me see. You wrote and another. I cannot understand why you wrote and another. What is that?
So, like I need to subtract those two both expressions.
But you have to write it now. How will I understand? Tell me.
Yes, sir.
Don't write answers in code languages. Tell me. How will I understand? Some encrypted code I have to decode. Anyways, so Mimel, you have understood properly one and two both. Anandit, is it clear?
Yes, sir.
Quickly solve number three if it is clear. Number three is very easy. We need to find out the sum of all the distinct four-digit numbers that contain only the digits 1, 2, 3, 4, 5, each at most once. Should I start? Tell me, everyone.
Sir, I sent it
Oh, you sent it.
a long time back.
Oh, yes, it is correct.
So can you once please check the solution of number 2 which I sent?
I'm checking. Yes, it is correct. It's the same way we have done it. See, you have also found out the total sum of all the numbers. See, that's what I did over here. Sum of all
Yes,
the
sir.
numbers. And then you have also found out the sum of all the numbers that are starting with zero. See, 6 into 12 into 4 ones. Oh, but you have written 5 ones.
Yes, sir.
Oh, that is not correct. It should be 4 ones, na? 6 into 12 into 4 ones. Tell me,
Yes, sir.
are you getting where you are making the mistake?
Yes, sir.
Okay, rectified. But have you understood, Shwamita, my solution also? Like
Yes, sir. I understand.
why there are 4 ones? Can you tell me, Shwamita?
So because we are excluding the first digit which is fixed as 0.
That is okay, but then why 4 ones? If the first digit is 0, it
So
becomes
the
a
rest of the four places we are taking as
4-digit number. Are you
four
getting?
digit number. Yes, sir.
Okay. Okay, so Anandit is only left for number 3. Anandit, should I start?
No,
Anandit
sir.
and
I'm solving
Devang.
it right now.
Devang, what happened? Number 3, tell me.
Sir, try to solve, please.
Quickly send. Long back you have sent me number 2.
It's at most once, but I can understand actually.
Means maximum you can use a number only once. At most means maximum. You cannot repeat it. Either you can use it zero number of times or you can use it one number of times. Understood?
Yes, sir.
Hmm.
Sir, I've sent it.
Yes, Anandit, your answer is correct. Okay. Yes, sir. Mimel, also your answer is correct. So I think only Devank is left. Okay, Devank, pay attention. Find the sum of all the distinct four-digit numbers that contain only the digits 1, 2, 3, 4, 5, each at most once. So pay attention. Okay. Using the digits each at most once, you have to find out the sum of all the distinct four-digit numbers. So the required sum. The required sum of all the distinct 4-digit numbers will be equal to.
Sir, is the answer 39960?
Yes.
Indra,
First of all, you need to select any of the four numbers. 5C4. Okay. Next. Now each of the digit will be there in each place how many times? 3 factorial times.
2 times. Yes.
5C4 into 4 factorial. That will give us how much? 120. Achha, this is the total number of numbers. 120. Achha, each of the digits will be there in the units place 24 times.
24
Are you
times.
getting? Each digit will be there in each place 20 times. 24 times. Okay. So the sum will be equal to 24 into 1 plus 2 plus 4 plus 5 into 4 ones. Okay. Next, let us do some more. So Devant, you have gone through the video, right? Tell me.
So that YouTube video
Recording. You were present last day, right?
last Monday.
No, yesterday. Yesterday you were present, right?
Yes, yes, sir.
Oh, achha, only Memir was not present. Okay, anyways, solve this one, everyone. Four, five. Quickly solve. Samita, check your answer again. Or Nini, check your answer again. Okay, everyone pay attention. Okay, we need to find out the number of devices of 240 of the form 4n plus 2.
Sir, my answer was for question 5.
Oh, your answer was for question 5. Ah, then it is correct. Okay, so everyone pay attention. Number 4. We need to find out the number of devices of 240 of this form. Achha, so first of all, let us identify what form it is. It is 2 into 2n plus 1. Right. Tell me. 4n plus 2 is equal to 2 into 2n plus 1. What does it signifies? Tell me. What does it signifies? This implies will we only need we only need the devices which are odd multiples of 2. We only need the devices which are odd multiples of 2. Okay. So let us first of all factorize it. 240 will be equal to 2 to the power 4 into 5. So we need only the odd multiples of 2. Okay. So first of all, let us take 2 common. We'll get 2 cube into 5. Now what do we need? Oh, wait a minute. It is 2 to the power 4 into 3 into 5. Sorry. 2 to the power 4 into 3 into 5. Now we need to find out the odd divisors of this particular expression. So the odd divisors of 2 cube into 3 into 5 will be how much? 1 plus 1 into 1 plus 1. That will give us 4. Tell me, is it clear to everyone? Anuni, Raktim, Anandit,
So can you
Devang.
please explain this part once again? The
Okay,
1
okay.
plus 1 into 1 plus 1.
Do you remember? Last day, yesterday only, I have taught you how to find out the number of divisors of a number.
Yes, sir.
Number of divisors of a number will be equal to alpha 1 plus 1 into alpha 2 plus 1 into alpha 3 plus 1, right? Tell me.
Yes.
Now, Shamita, we need only the odd divisors of this particular expression, right? Because I've already taken 2 common, right?
Yes, sir.
So that means I need to choose only those shops where 2 is not present,
Okay, sir.
right? That is 3
Yes.
and 5. Right, tell me, Shamita. What is
Yes,
the
sir.
power of 3? Power of 3
1.
is 1. Power of 5 is 1. So it will be 1 plus 1 into 1 plus 1.
Yes, sir.
Is it clear?
Yes, sir.
Tell me, Devang, is it clear?
Yes, sir.
Raktim, is it clear?
Yes, sir.
And Shamita, is it clear? Onini,
Yes, sir.
Lemel.
So I wrote it as 2 into n plus 1 instead of 2 into 2n plus 1.
Oh, so I hope you have understood now.
Yes, sir.
Anandit, is it clear?
Yes, sir.
Okay. Stop number 5 quickly. Now you have to find out those devices which are perfect squares. Think about it. Tell me, should I start, everyone?
So Yes, Onini, right answer. Okay, Anandit, Raktim, Devang, pay attention.
Sir, 1 minute.
Okay, send. Yes, Ratim, your answer is correct. Email, is it done? Yes, Anandit, your answer is correct.
Ascending.
Memel, your answer is correct. Okay, then who is left?
So Swatin, please wait.
Sign quickly.
Sir, I've sent.
Yes, Devang, your answer is correct. So I think everyone has given the answer. Okay, the answer is 120. Next, I'm going to discuss a new topic. Okay, but before discussing new topic, Memel, can you hear me?
Yes, sir.
Memel, can you tell me the process of question number 5? What did you do?
Sir, I'm sending.
Send. Okay, our next topic is distribution of alike objects. Okay, and Shomita, you also send me the process.
So question number 5.
5.
Yes.
Distribution of alike objects. Or you can say Beggar's method. Okay. Okay, in many books, it is also taken as stars and bars method. Okay, Beggar's method. In many books, it is also written as stars and bars. Stars and bars method. Okay, all are same. Distribution of alike objects. And it is very important. It is very important for JE. JE Advanced also questions have come from here. And Olympiads also. All kinds of Olympiads. So Shomita, what are those two choices which you wrote? Can you tell me what are those two choices?
Yes, sir. So can you please one show the question?
Ah, yes. What are those two choices?
It's a perfect square. So 2 cube, it is 0, 1, 2. So uh,
0, 1, 2, 3.
1, 2,
All
3. So
uh,
from there only two of them are perfect squares.
Which ones?
And
Which ones?
sir, the even powers, that is 2 to the power 0 and 2 square.
Okay, okay. I understood your method. No need to explain anymore. And Mabel, I'm still waiting for yours.
Sir, I've sent.
Oh, you sent. Let me see. Acha, for 5 you wrote the possible values are 0, 2, 4, 6. Why 0, 2, 4, 6? Hmm? Mabel, for 5 you wrote 0, 2, 4, 6. Why you wrote 0, 2, 4, 6?
Because, sir, like till 6 it can go.
Why didn't you include 1, 3, 5? And what are these actually? 0, 2, 4, 6.
Sir, the exponents, like if I consider
Okay,
it
okay, okay. I
to,
understood, I understood. So why didn't you consider 1, 3, 5? You considered 0, 2, 4, 6. Right, there should be a reason, right? Why didn't you consider 1, 3, 5?
sir, for 5.
For 5 only, I'm asking. Why didn't you consider 1, 3, 1, 3, 5? For 5, you considered, okay, Memel, for 5, you considered 0, 2, 4, 6, isn't it? Tell me.
Sir, to be like perfect squares, the exponent should be even
Okay,
integer.
okay, okay, okay. I understood. Okay, no need to explain anymore. I have understood. Okay, so everyone pay attention. Distribution of alike objects or Beggar's method or stars and bars. So suppose, suppose you have been to a temple, right? How many of you have been to a temple? Anyone who has never been to a temple, tell me. Is there anyone in the class? Everyone has been to a temple, right? Tell me.
Of
Memel or
course.
Nini? Of course, right. Or Nini, you have been to a temple?
Sir,
Which one?
sir, I've been to the one at Puri, I think.
Puri. So
Yeah.
don't go to the temples which are nearby. You take a train and go far away to temples, right?
Sir, I don't go to pray on
Okay.
daily basis. I just went to see the place.
Ratim, you have been to a temple?
Yes, sir.
Which one?
Yes, sir. Many.
Many. And Samita?
Yes, sir.
Okay. Anyways, uh, so from now till JE mains also you people go to temple frequently. It will be better.
Yes, sir, yes, sir.
Yes, it is highly required. You people know. Okay. Anyways, so suppose we have 10 coins, 10 identical coins. Okay, everyone, and three beggars. Okay. So suppose there are 10 identical coins and there are three beggars. Okay. And you want to distribute 10 identical coins to three beggars. Okay. Now try to understand. If you make a linear arrangement, okay. If you make a linear arrangement, okay. In this case, there can be a confusion. Okay. Like you won't be able to understand. Okay. Now let us say the three beggars. Okay. The three beggars. Okay. You have arranged the coins in a linear way. Okay. In a plate or something, any tray, and the three beggars came to you and picked up all these 10 coins, okay, and went away. So, will you be able to identify which beggar has got which coin? Tell me. The three beggars came to you, took away all the coins, and went away. So, will you be able to identify which beggar has got how many coins, or which coin is went to? I mean, which coin, which beggar has got four coins or five coins? Will you be able to understand? Tell me
Yes.
how.
So the beggars are not identical, right?
Beggars are not identical, but once they took away all the coins, will you be able to understand how many coins they've got?
So why can't we tell who has four and who has five?
Like you have to go and count, right?
Right.
Sir,
Isn't
if
it?
I see them, I mean, in front of me taking it, then I could have able to understand because the positions I could have seen that from where they are taking.
Exactly, exactly. So you should be able to, like you have. I mean, uh, you will be able to say whether the first beggar has got four coins only if they have taken from the first four, or middle four, or the last four, isn't it? Tell me, yes or no? If they take it in front of you, but once they have taken and went away, you won't be able to tell until unless you go to that beggar and count the number of coins in his hand. Yes or no? Tell me. Are you people getting my point? Okay. But at the moment, if I ask you, at the moment you have to count in how many ways you have distributed, and in how many ways, how many coins the first beggar has got. Okay. How will you tell? For this reason, okay, in order to distribute for this reason, what you do is you make a partition in this 12 coins, in this 10 coins, you make a partition, make three partitions. So in order to make three partitions, let us introduce two fake coins, introduce two alike fake coins. Okay, everyone, introduce two fake alike coins, two alike fake coins. Okay, so now what will happen? Now the linear arrangement will look somewhat like this. Now the linear arrangement will look somewhat like this. Tell me. Yes or no? Tell me, everyone. Okay. Now you ask them. Okay, to take the coins from the first part. First beggar can take the coin from the first part. Second beggar can take the coin from the second part. After the first fake coin, and after the second fake coin, the third beggar can take the remaining coins. Now you will be able to understand uh, how many coins the first beggar has got, how many coins the second beggar has got, how many coins the third beggar has got. Are you people getting? Tell me. As you move the coins, try to understand. As you move the fake coins in this linear arrangement, you'll be able to understand. You'll be able to understand how many coins the first beggar is getting, how many coins the second beggar is getting, how many coins the third beggar is getting. Are you getting? Tell me, everyone. So in this case, the first beggar is getting how many coins? Tell me. In this case, the first beggar is getting how many coins? Three coins. Second beggar is getting how many coins?
Five.
Five coins. And the last beggar,
There a necessity that the first beggar will take the coins from the first slot only.
you have assigned it. You have assigned the first partition to the first beggar only. Are you getting? So the he will come and take the first three coins. Okay, he cannot take the second partition. The second partition is for the second beggar. Are you getting?
Sir,
Tell
that
me, Noor.
choice at first mind, like I mean, like I will assign them in from which slot they are taking it.
Exactly. 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 You will assign it. Okay.
Okay, sir.
Now, what is the benefit of assigning? We will understand after a few minutes. So tell me, the first beggar is getting 3 coins, second beggar is getting 5 coins, and the last beggar is getting 2 coins. Now, see what is the benefit of assigning? As you move the fake coins to the left or to the right, pay attention. See, I have moved it. I have moved it in front. Now tell me, the first beggar is getting how many coins?
One,
Second beggar is getting how many coins?
seven,
7. Last beggar?
two,
2. Okay. Now you tell me, the second beggar is getting how many coins?
0,
And the last beggar?
9.
9.
9 coins. Are you people getting what is the benefit of making partition? You are able to
Yes.
identify. You are able to get. You are able to understand in how many ways you are able to distribute 10 coins. Okay, these are the number of ways you are able to distribute 10 coins. Next, in this case, tell me, the first beggar is getting how many coins? In this case, the first beggar is getting how many coins? Tell me.
7.
7. Second beggar is getting how many coins?
2,
And the third beggar is getting how many coins?
1.
1 coin. Okay, tell me, Anandit, are you getting?
Yes, sir.
Memen, are you getting?
Yes, sir.
Okay. Shamita?
Yes, sir.
Okay. So basically, I'm showing another one. Wait a minute, I'm showing another one.
Yes, so number of ways is 11 square.
Over here, tell me, first beggar is getting how many coins? 2.
2,
Second beggar is getting 2. Third beggar is getting 7 coins. No, 6. Okay. So write it down. First partition is allotted to the first beggar. Is allotted to first beggar. Second partition is allotted to second beggar. And third one is allotted to third partition is allotted to third beggar. Okay, everyone. First partition is allotted to first beggar. Second one is allotted to the second beggar. Third one is allotted to the third beggar. So basically, everyone pay attention. What am I doing? I'm actually arranging these two fake coins between these identical original coins. Yes or no? So here you will understand while distributing. Here while distributing, you can understand. We can conclude. Okay. So see everyone, while distributing, while moving fake coins between in this linear arrangement, you are actually arranging all these 12 coins in which 10, 10 are original and 2 are fake. Yes or no? So basically it is the number of ways to arrange 12 coins in which 10 are identical of one kind and 2 are identical of another kind. Yes or no? Tell me. Raktim, Samita, are you people able to understand? Basically, you are arranging, right? You are arranging 12 things in which 2 are identical of one kind and 10 are identical of another kind.
Yes, sir.
Tell me, Onmini, are you able to realize this?
yes,
Memen, tell
Yes,
me.
sir.
And Devang, are you able to realize this?
Yes, sir.
So here while distributing, you can conclude that the number of ways to distribute, or you can say the number of ways of distributing 10 coins, 10 coins to 3 beggars is equivalent to arranging 12 coins, in which 10 are alike, in which 10 are alike original coins, 10 are alike original coins, and 2 are alike fake coins. Fake coins. Okay. So number of ways will be equal to 12 factorial divided by 2 factorial into 10 factorial. Okay. Which can be written as 12C2. So I'm going to generalize this. Okay, generalization. Okay. Suppose there are n coins and p beggars. Okay, number of ways. Yeah, n coins and p beggars. So how many fake coins you need to introduce? Number of fake coins to be
P minus
introduced will be equal to p minus 1. So number of ways to distribute. Number of ways to distribute will be equal to n plus p minus 1 whole factorial upon n factorial into p minus 1 whole factorial, which is equal to n plus p minus 1 cp minus 1. Then is it clear to everyone? N plus p minus 1 cp minus 1. Okay. Next. Everyone, there is a theorem. Total number of ways to distribute n identical coins to p persons such that each receives at least one. Means none of the beggar goes home without a coin. Okay. None of the beggar goes home without a coin. Okay. So at first only what you do is, you give 1 coin to all the beggars. Okay, at first only you distribute one coins to all the beggar. So how many coins you have already distributed? Tell me. One coin to each beggar. At first only, how many coins you have distributed? Tell me everyone. How many coins you have distributed?
50 coins.
Three coins. Three coins you have already distributed. So number of coins left. How many coins are left? Tell me. Devang, tell me how many coins are left after distributing one coins to all the beggars?
E minus 1.
P minus one.
Sorry, n minus 1.
N minus one. You have distributed one coin to each beggar. How many beggars are there?
So n minus p.
N minus P, right? What happened? Devang, N minus P. Because you
Yes,
have given one coin to each beggar. So in total, you have distributed P coins.
P
Number of
minus.
coins left will be N minus P. So what is the number of ways to distribute N minus P coins? Tell me, to P beggars. It will be equal to N minus P plus P minus 1, CP minus 1. Right, tell me everyone. Minus P plus P gets cancelled. You are going to get N minus 1, CP minus 1. Are the people getting? Yes or no? If there's anyone who couldn't understand, you can ask me. Tell me. Raktim, Navandit, did you people understand?
Yes, sir.
Yes.
Soumita
Yes, sir.
or Nini,
Yes, sir.
Mimim,
Yes, sir.
Devang.
Yes, sir.
Okay. Next, there's another thing. Pay attention.
Sir, I have a doubt in the previous.
Yes, yes,
So
tell me.
what is so what about in number of coins coin will be not one less than the number of beggars?
Aha, I couldn't understand.
Sir, in the previous case we was considering like the number of coins are one just one less than the number of beggars. So the condition in which case that condition does not make sense.
Couldn't understand. What did you say?
Sir, in the previous case.
In the previous case, huh? What?
So here we considered the number of coins are number of person are p and number of
Hmm.
coins are p minus one. So that's why I was saying.
Number of fake coins you have introduced P minus 1, na? Why did
Yes,
you introduce P minus 1 coins? Tell me.
it's a number of frequent that I'm saying.
Huh? How many fake, I mean, so number of fake coins,
So, so I was
why
just
did,
is it necessary that it should be one p minus one?
couldn't understand. P minus 1. What are you asking? Tell me.
Sir, I was telling the number of fake coins are p minus one and the number of
Correct.
beggars are p. So is
Huh?
there any relation in p and p minus one? Like can I say the fake coins are p minus two or something p?
So that is why I'm asking you, right? Why did I introduce P minus 1 only fake coins? Why did I introduce 1 less than the
Yes, sir.
number of beggars?
Yes, sir.
Huh? Why?
So that I was
Why did I?
asking.
That only you are asking.
Yes,
And previously, I introduced two fake coins. There were three beggars. Why did I introduce two fake coins? What was the reason I introduced two fake coins?
yes, sir. Now I understand.
To make free partitions, right?
Yes, yes. Now I understand.
So, in order to make P partitions, how many fake coins you need to
P
introduce?
minus one. Now I understand.
Yes. Okay. So over here, you'll get n minus 1 Cp minus 1. What's the next?
Sir, I had a doubt.
Tell me.
Sir, in the like the example, we have 10 coins, right? So there are 11 gaps between them. Now, since each beggar needs to get at least one, both of the partitions cannot go in the same gap. So why can't we do it as 11 into 10 divided by 2 factorial? That is yielding a different answer.
Couldn't understand. Like what you want to do?
So there are 10 coins, right? So there
Uh,
are 11 gaps.
10 coins, then 11 gaps.
Sir, there are one beggar needs to get at least one coin, so both of the partitions cannot go in the same gap.
Okay, both the coins cannot go in the same gap. Okay,
Okay, no, sir, I got it, I got it. It cannot go in the edges either, so that's what I
exactly,
was
exactly.
thinking. We can do it as 11 into 10 by 2 factorial.
Oh, acha. I understood. I understood what you meant
No,
to say.
it'll be 9 into 8 since it has to go in the middle. So it's the
Hmm.
same. Yeah.
Yes. So have you understood? Or maybe Devang, did you understand?
Yes, sir.
Okay. Mimel, did you understand Vegas method? So next, in the first example, I wrote B1 plus B2 plus B3. I mean, there are three beggars. In total, how many coins they will get? B1, B2, and B3 in total, all together will get how many coins? Tell me.
10.
10 coins. Okay. One of the possibility, one of the possibility is 019, right? One of the possibilities is that B1 has got 0 coins, B2 has got 1 coin, and B3 has got 9 coins. Another possibility is 217. Another possibility is 550. Right. Another possibility is 334. Yes or no? Tell me, everyone. These are the possibilities. Yes or no? So what are these, everyone? These are actually non-negative integral solution of this equation. Yes or no? Tell me. All these are non-negative integral solutions of this equation. So can I say that the non-negative number of non-negative integral solutions of the equation x1 plus x2 plus x3 plus x2 xp equal to n is the number of ways to distribute n coins to p beggars. This will be equal to n plus p minus 1 cp minus 1. Right, tell me, Raktim, Anandit, are the people getting? And if I ask you what is the number of natural solutions, what is the number of natural solutions?
N minus 1, CP minus 1.
Exactly. Samita, did you understand properly? If you have
Yes.
any doubt, Memel, did you understand?
Yes, sir.
Anandit, Devang, Raktim, did you people understand?
Yes, sir.
Yes, sir.
If you people have understood, let us do some problems. Okay, start. Okay, once I've done it, keep sending your answers. Yes, rectangle number 6 is correct. The distribution of alive objects is very safe, very much important. Yes, on any right answer. Rectangle, which answer is this? 7.
Yes, yes.
Correct, correct. Okay, Anandit, the answer which you sent me, the recent one, which answer is that? Number?
6, sir.
So, another check number 6. Only 7 is correct. Memel, check number 7. Samita, check number 6. Ratin, check number 8. Oh no, Anandit, number 6 is correct. Samita also 6 is correct. So who is left for 6? Devang, 6 is correct. So I think 6, everyone has solved it. Oh, Memel. Memel, I'm solving number 6. Pay attention.
Sir, 1 minute, I'm simplifying.
Okay. You can give the answer in terms of expression also, no problem.
Sir, in question number 7, is that 102?
Yes.
Okay, sir.
Sir, I've sent.
Yes, it is correct. Number 6, everyone has solved.
Sir, 10 is polygonal.
Yes. Where? Over here?
Mm, yes, sir. Yeah. Yes, sir. Done. Sir, done.
Okay.
Sir, is it written number of not natural solutions in the theory part, or is it number of natural solutions?
Number of natural solutions. Number
Okay.
7. Yes, 7 is correct. Shomita, Nandit, Devang. 7 is correct.
No, no, sir, I was not asking about the question. I was asking before question 6, is it number of not natural solutions?
Oh, number of natural. Actually, by mistake, I wrote an 80.
Yes.
Okay, we will check number 7. Okay, I'm solving 7. 6, everyone has solved it. I'm solving 7. Okay, who is left for 7? I think Memel, Devang has done it. Okay, Devang, number 8 is correct. Okay, so Memel, I'm solving number 7. We need to find out the number of natural solutions. So, what is the problem? Number 7, it is a direct question.
Sir, in number 9 is the second coordinate 0, 102.
Second coordinate.
In number
Number.
9
Yes, 0, comma 1. Okay, so it is x plus y plus z is equal to 102, right? So there are 102 coils and there are 3 beggars, right? We need to find out the number of natural solutions, right? Tell me, Mimel. So it will be, it's the right question. Number of natural solutions will be equal to, will be equal to 102 minus 1, C2 minus 1. Sorry, C3 minus 1. That is 101 C2. Is it clear? Tell me.
Yes.
Yes, Shomita, number 8 is correct. Anandit, 8 is correct. Okay, should I start 8, everyone? I think Konvini, Raktim, and Mimil are left. Pay attention. Number 8. Before starting 8,
Sir, send it.
yes, but Mimil, you have to simplify this, isn't it? Your answer is correct though, but simplification is required.
Sir, I haven't sent it yet.
No, no, on mini. Oh, I said Mehmed. My mistake. On mini, you have to simplify this.
Okay, sir.
Anyways, uh, Devan, can you hear me?
Yes, sir.
Devan, can you explain your solution for number 8? Can you
Sir,
explain?
it is written that the entire part is less than equals to 30, so I think we have to introduce another variable so that we have to make it equivalent.
Yes.
So that's why there will be five variables, and so instead of four, I've written five in their output.
Okay. Okay. So what you do is, everyone pay attention. It is x plus y plus z plus t is less than or equal to 30. So let us say, let there exist another variable. Let there exist another variable p such that x plus y plus z plus t plus p is equal to 30. Right, tell me. Raktim, are you getting?
Yes, sir.
Raktim, Memel, Omnini, are you getting? If p equal to 0, then x plus y plus z plus t is equal to 30. If p equal to 1, x plus y plus z plus t is equal to 29, then 28, 27. Right? For different values of p, you are actually getting this inequality. Right? So number of non-negative.
36 C4.
Exactly. Integral solutions will be equal to 30 plus 5 minus 1, that is 34 C4. Right. Memel, is it clear? Memel, Omnini, is it clear? Tell me.
Yes.
Yes, sir.
Okay, but Omnini, the way you have solved it, you can simplify it from there also. Okay, I'm doing the simplification. Method 2. So everyone, this method is done by Omnini. So basically, you need to find out the number of non-negative integral solutions of x plus y plus z plus t equal to 0, x plus y plus z plus t equal to 1, x plus y plus z plus t equal to 2, plus dot 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 dot, x plus y plus z plus t equal to 30. So tell me, in the first one, what is the number of solutions? What is the number of non-negative integral solutions in the first one?
3C3 then.
Will be equal to 3C3. In this one, 4C3. In this one, 5C3. Right, dot 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 dot. This one will be 33C3. So what is the total number of solutions? Total number of solutions will be equal to 3C3 plus 4C3 plus 5C3 plus up to 33C3. So everyone, instead of 3C3, can I write 4C4? Tell me, can I write this instead of 3C3? See, how can we simplify this? And it's a very important simplification. Simplification of this binomial series is important. Okay. Questions have come in the past in JEE mains. You see PYQs, you will understand. Can I write 4C4 instead of 3C3? Tell me everyone. Onmini, Shamita, Anandit, Memel, Devang.
Yes, sir.
Okay. Acha, what is What is NCR plus NCR plus 1? Do you people remember? What is NCR plus NCR plus 1? You people remember? the identity NCR plus NCR plus 1. I did it in the beginning when I was writing the formulas for NCR. What is NCR plus NCR plus 1? Do you remember that ball example? Tell me. Where there are n balls in the box, I have to choose R balls. Do you people remember? Nobody remembers. What is NCR plus NCR plus 1? Hmm?
Sorry, I think it's n plus 1 CR.
No, no one remembers. Surprising.
So
Don't
in
forget.
yeah.
Huh? By the end of this year, how many things do people need to remember? See, so many concepts are there, but you people are forgetting in just 2, 3 weeks. Do people remember? I did this proof by two methods. What is NCR plus NCR plus 1? N plus 1 CR plus 1? Can you people recall?
Yes and no.
Hmm? By the end of this year, how many things you people need to remember? Don't forget. Raktim, are you getting?
Yes.
So it will become 5C4 plus 5C3 plus up to 33C3. Now tell me, what is 5C3 plus 5C4? Tell me. 6C4 plus 63 plus dot plus 33C3. If we keep on going like this, in the end, what will you get? 33C4 plus 33C3. So tell me, what is 33C4 plus 33C3? 34C4. Tell me, is it clear to everyone? How can we simplify this series? Binomial series, tell me.
Yes, sir.
Swamita, Raktim, Anandit, Devang, did you people understand?
Yes.
Let me solve number nine then. Yes, Swamita, your answer is correct. Should I start, everyone? Tell me. Okay, so everyone see. So basically, let us plot the points, first of all.
Sir, I've sent it.
I've sent it. Let's see. Nini, check your answer again. Anandit, right answer. Raktim, check your answer again. Okay, so everyone pay attention. You need to find out the number of points with integral coordinates that lie inside the triangle whose vertices are 0, 0, 0, 102, and 102, 0. So let us first of all plot the points. Okay. Let us first of all plot the points. So this is 102 comma 0. This is 0 comma 102. Okay. Acha, I'm marking one line. Okay. So this is y equal to 1. Okay. In this line y equal to 1, let us check how many points are there which are lying inside the triangle. So it will start with 1 comma 1, then 1 comma 2, then 1 comma 3, then dot 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 dot. This point, what is the coordinates of this point? Can anyone tell me? This line is y equal to 1. What is the coordinates of this point? Can you tell me? What is the equation of this line? Tell me, everyone.
Sir, x plus y equal to 102.
X plus y equal to 102. So quickly tell me what is the coordinates of this point?
So 101 comma 1.
1, 0, 1, comma
1.
1. So actually, the coordinates of this point will be 1, comma 1, then 2, comma 1, then 3, comma 1. So in total, how many straight lines, how many points lie on this line which are inside the triangle? Tell me, how many points will lie inside the triangle?
So 100.
100. Next, let us take another line, y equal to 2. So in this line, how many points will lie? Tell me. In this line, how many points will lie? 99.
19.
Then in this line,
98.
98. Dot 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 dot. It will go up to only 1. So what is the number of points? Number of points will be equal to 1 plus 2 plus 3 plus up to 99, which is 101 n into n plus 1. That's 99 into 100 divided by 2, which is 5050. But wait, it should be 100 plus 99 plus 100. So 100 into 101 divided by 2, 5050. Is it clear to everyone? Raktim, Nini, is it clear?
Yes, sir.
Devang,
Yes, sir.
Yes, sir.
this is method 1. Method 2, what is the equation of the given line? Equation of the line is x plus y equal to 102, right? So we need to find out. To find out integral solutions, to find out integral points which lie inside the triangle, try to understand the coordinates of those point. The coordinates of those points will be the number of non-negative integral solutions, right? So here we need to find not non-negative, natural. We need to find natural solutions of x plus y is less than or equal to 102. Right? Tell me, everyone. Just let me know if you can understand this. Hmm? Raktim, Anandit, Devang, Samita, are you people getting? We need to find out the number of natural solutions of this inequality. Or Nini?
Yes.
Yes, sir.
Yes, sir.
Right. That will give us all the points that lie inside that triangle. Okay. So again, using the previous method, right, we introduce a fake variable. So introduce another variable. Okay, we get x plus y plus z equal to 102. So the number of points will be equal to 102 minus 1, C2 minus 1, C3 minus 1, which is 101 C2, which is 5050. Is it clear, everyone? If you have not understood, you can ask me, tell me. Okay. Okay, so let us do another one. Wait, I'm posting. Okay. So anyone has any doubts till now? Team, you have any doubt till now?
No, sir.
Okay. Solve. 10 and 11. Okay, Nini, this is the answer of number 10.
Yes, sir.
No, check it again. Yes, Raktim, number 10 is correct. Devang, 10 is correct. Okay, let me start number 10. Okay, so only pay attention. Yes, Mimel, Anandit, your answers are correct. Okay, only I'm solving. You need to find out the number of ways 30 marks can be allotted to 8 questions if at least 2 marks are to be given to each question, among assuming that marks are to be allotted in non-negative integral values. So Mimel, no, I mean, Onrini, at first you give 2 marks to each question. Okay, how many marks are left? Tell me.
14.
14, number of marks left will be equal to 14. After distributing 2 marks to each question, so the number of ways will be equal to 14 plus 8 minus 1, C8 minus 1. That gives us 21 C7. Is it clear? Or Nini, tell me.
Yes, sir.
Okay. Solve 11. 11 is easy.
So actually, the way I had done it was like there are 30 marks. So you can create 15 units of 2 marks each, right? And each question needs to get at least one of those units. So I selected 14C7.
Oh, but actually
But
that
then,
creates a
yeah,
problem.
yeah, so what was the problem?
You tell me what is the problem. Think.
So I cannot understand that.
Yes. A particular question can get only even numbered marks. Why can't it get odd numbered marks?
Okay, sir, okay, sir.
Right. Can a question not carry 3 marks?
Yes, sir.
That is why you see your answer is less than what I have got.
Yes, yes. Okay, sir.
Hmm. Yes, Devant, number 11 is correct. And Reptile, these are the answers of part 1 and part 2, or
Yes,
how
sir.
it is?
Part one and two.
In that order only, right?
Yes, sir.
Check it again. Okay, Anandit, check your answer again. Maybe part one is correct.
Uh, Sir,
Tell
sir,
me.
sir, in my
Hmm.
answer, the order should be reversed.
Then it is correct.
By mistake, I think.
Okay, Anandit, I'm solving this one. Anandit, Onini. Okay, so Anandit and Onini, pay attention. Okay, Onini has sent. Part one is correct. Okay, Anandit, pay attention. Anandit, can you hear me?
Yes, sir.
So over here, Anandit, there are unlimited number of red balls, blue balls, green balls, and white balls. They are all alike except for color. Find the number of ways that we can select 10 balls. Okay. So let X be the number of blue balls selected, XG be the number of green balls, XW be the number of white balls.
Sir, for one I solved it and sent you the answer right now.
Okay. Can you explain? Can you explain? Hello, Anandit, am I audible?
Yes, sir. Yes, sir.
Can you explain?
Sir, I use the formula that n plus one, n plus k plus one minus n plus k minus one c k minus one, where I knew there were 10 and 4, 10 plus 4 minus 1 it was coming in the top, so 13 c 3 it was coming at the end, and I solved it.
But why 13 plus 4? Cannot understand. Like, why 13 plus 4? I mean, 10 plus 4. Can you explain in more brief? I mean, briefly, tell me. More details I need.
So there are 4 colors, and there are
Okay.
10 of 10 balls, so
10 balls. There are only 10 balls. It is written there
oh
are
no, no, sir,
unlimited
I
number
read
of
it wrong.
balls.
I read it wrong. Sorry, sir. Sorry, sir. Net is here is bad. I read it wrong. So you can you
Okay.
solve it,
How did you get this answer? Hmm?
sir? I read it as 10. Saw it wrong. Well, net is here is bad.
That is okay, but whatever answer you wrote, that answer is correct. But how did you get it? And there must be a reason, right? You are getting so accurate answer and that too correct, but you are unable to explain the solution. Can you tell me how?
Sir, we have to choose 10 balls from here. Oh, you have to choose 10 balls from here in the given question. So, like,
Hmm.
I use the formula that the total number of balls that I have to choose is 10, and the color given is 4. So, like, the formula, as per the formula, so 10 plus 4 minus 1, I did like that.
Why 10 plus 4 minus 1?
So the number of colors is 4.
Okay.
Like 4 colors, 10 balls, and in that way.
So my question is, will it be always like this? That means you have to select 4 balls, okay, and there are 10 balls you need to select. So the number of ways will be 10 plus 4 minus 1, C4 minus 1. But this formula is used to find out the number of ways to distribute, right? Not for selection, isn't it? Tell me.
Yes, sir.
The number of ways to distribute n coins to p beggars will be equal to n plus p minus 1 cp minus 1, or the number of non-negative integer solution is equal to n plus p minus 1 cp minus 1. So
Yes,
why
sir.
did you use that formula over here? Are you getting? Over here we need to select. Why did you use that formula n plus p minus 1 cp minus 1 over here? Can you tell me? Hmm? There must be some reason, right? Why did you use that formula over here? Can you explain? Anandit, are you there? Am I audible to others?
Yes, sir.
Anandit, can you hear me? Tell me,
Yes, sir.
what happened? I'm asking you a very simple question. Why did you use that formula over here? What is the reason?
Sir, I can't understand. Like, did I do a mistake? I
No, no. See, I've got a correct answer,
Yes,
but
sir.
I just want to know why. I mean, how you got that correct answer? Like, there should be some reason, right? I mean, you cannot get a correct answer without a proper logic, right? Tell me. So I want to know what logic you used, what went through your mind that you got this answer. Are you getting? There should be a proper explanation. Yes or no? Tell me. Anandit, there should
Yes,
be a
sir.
proper, isn't it? Can you do something? Can you do something in maths without a proper logic or proper steps? Tell me. Yes or no? Can you do something? It's not possible, right? Whatever you do, you should be able to explain. Yes or no? Tell me, Anandit. So that is why I'm asking. Like, I want to know what was going through your head when you got that answer. I mean, how you got that answer by just simply using a formula. And why did you use that formula only? I gave you hundreds of formulas. Tons of formulas I have given you, isn't it? Tons of formulas I have given you. Why did you use that formula only specifically? Understood, Anandit, what question I'm asking you? Hello, Anandit, what happened? Hello, Anandit, can you hear me? Don't keep quiet. Okay, I'm explaining. Pay attention. Anandit, pay attention. I'm explaining. Can you hear me or not? Tell me.
Yes, sir.
I'm explaining. Pay attention. Let XR be the number of red balls selected. Okay. Let us say that you have selected XR number of red balls. Okay. XB be the number of blue balls selected. Okay. Let us say you have selected xg as a number of green balls and xw is the number of white balls selected. Okay. So what should be the total number of selection? Tell me, Anandit. What should be the total number of selections?
So 10.
10. Right. So see, it became an equation, right? Tell me. Are you getting Anandit? It became an equation.
Yes, sir.
So the number of non-negative integral solutions will give us the number of ways to select 10 balls. Yes or no? Tell me. Are you
Yes,
getting?
sir.
So the number of ways. Okay. See, this is the proper logic. This is why you are getting 13C3, 10 plus 4 minus 1, C4 minus 1. Now we can use that formula. Are you getting? Because the number of ways, number of non-negative integral solution of this equation will give us the total number of ways that we are selecting these 4 balls. Right. Now, is it clear? Tell me, Anandit.
Yes, sir. Thank you, sir.
Okay. So from now on, whatever you are doing, okay, you should be able to explain. Are you getting, Anandit?
Yes, sir.
Okay. First of all, understand, analyze, then solve it. So similarly, tell me what is the answer of number two? You need to select 10 balls containing balls of all colors. Tell me what's the answer of number two? Containing balls of all colors means you need to select at least one. Right, tell me. At least one of each color. Tell me.
Yes, sir.
So over here, what do we need to find out? Number of. Over here, what do we need to find out?
So number of balls of each color.
Num Again, number of balls of each color will be there.
Oh,
So
so
we need
sir.
to choose at least one ball, right?
Yes. So it will be 10. So there will be. One second, sir.
Will be equal to the number of natural solutions, right?
Yes, sir.
Now, Anandit, pay more attention in the class. It is important. You can understand. Okay. The people who gave JEE Mains first attempt, they are highly frustrated, highly disappointed. You know it very well, right? Everyone knows how the first mains went for the people, for everyone, how the paper was. It is not a cup of cake anymore. Okay. NTA has started setting tough papers and lengthy papers. Whatever marks you are getting in test, in your tuitions, just cut off 20-30% marks. Okay. So 9C3. Tell me, did you people understand? Anandit, is it clear now? Properly?
Yes, sir.
Okay. Pay more attention in the class. It is important. Okay. Nima, did you understand part two?
Yes.
Okay. Next. Okay. So Nini, you have done it like this only, right?
Yes, sir.
Okay. Next. Another problem.
So I didn't write the equations. I just like saw the similarity. Like from each color we can select any number of balls. So here the colors become the beggars.
Okay.
Like each beggar
Yeah.
can receive any number of coins.
Okay.
And
So you have compared it with the number of beggars, right?
yeah, that's it, right?
But this was better, right? Like considering four four variables. and getting an equation. But anyways, whichever method you like. Okay. Quickly solve everyone. These are also very easy. By the next week, I'll move on to another chapter. That is binomial theorem. So keep practicing, everyone. Okay, very soon PNC binomial test will also be taken. Okay, keep practicing. Yes, only the right answer. Let him check your answer again. Number 13 is correct. Okay, should I start, everyone? A man has to buy 25 mangoes.
Sir, please wait.
Okay, solve.
Sir, can you check your WhatsApp once?
Can you check your answer again? Yes, Anand, Devang, your answer is correct. Okay, so who is left?
But is that substitution which I used, is that okay? Like I use a substitution in that part.
Mm-hmm. Correct, correct. Okay, so who is left for the first one? I mean, number 12. Okay. Yes, Anandit, your answer is correct. So I think everyone has given the answer. Who is left? Anandit has given.
Yeah,
Devang.
I have not checked the answer.
Yes, Ratil, pay attention. A man has to buy 25 mangoes for four different varieties, buying at least four of each. At least four of each means at first only you buy four of each mangoes. In the beginning, you purchase four of each mangoes. Right?
Then we have to get solution n minus 1 to r minus 1.
No, 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 no. But after purchasing four of each mangoes, then you can distribute the mangoes in none one or more method. Right or not? Non-negative integral solutions. Are you getting?
Yes, sir.
So there are four different varieties, na? X1 plus x2 plus x3 plus x4 should be equal to 25.
Yes,
Right? Tell me.
yes, sir.
Now, if you purchase four of each variety, if we purchase four of each variety, now what will be the equation? Now the equation becomes x1 plus x2 plus x3 plus x4 is equal to 25 minus 16, which is 9. Now, even
Yes, sir.
if one of them is equal to 0, no problem.
Yes, sir.
So number of ways will be equal to 9 plus 4 minus 1,
3
C4
4
minus.
plus.
So 12
I
C3.
yes. I understood the question wrong actually.
Okay, I'm solving 13 also. Okay. 13, I think Anandit is left and Devank is left. Raktim is also left. Okay. 13, we need to find out the number of different floors. in throw
Sir,
of
is
n
my
dice.
answer correct?
Yes, your answer is correct. In a throw of n alike dices. So pay attention. There are n alike dices. Okay. So what are the numbers you can get when you throw a dice? What are the outcomes? Let x1 be the number of times we get 1. X2 be the number of times we get 2. X3 we get X3 be the number of times we get 3. Are you getting? Means we have thrown n dices. And let us say 1 you have got 1000 times, 2 you have got 4000 times, 3 you have got 0 times. Are you getting? And X6 you have got 6 times. Sorry. X6 with the number of times we get 6. So what should be X1 plus X2 plus X3 plus X4 plus X5 plus X6? Tell me. What should be the number? Tell me. Total number of dices. How many dices are there? Everyone, how many dices are there?
n.
N dices. So this will be equal to n. Okay. This implies number of ways will be equal to n plus 6 minus 1, c6 minus 1, which is n plus 5, c5. If you people have any doubt, you can ask me. Tell me. Go on. Acha, this was 13. Okay. Number 14. Find the number of ways in which 2 apples, 3 oranges, 4 mangoes can be distributed between A, B, and C. If each child receives none, one, or more number of fruits.
Sir, can you please scroll down to the solution of 13? I missed out one part.
Yes, tell me.
Yes, the last
Oh,
line actually.
okay. Actually, on me, I have got a different answer. Should I start, everyone? Okay, so everyone, I'm solving number 14. We need to find out the number of ways in which 2 apples can be distributed. Acha, so tell me, in how many ways can you distribute 2 apples among 3 child? In how many ways? This is number 14. Number of ways to distribute apples. Distribute apples. Apples are alike will be equal to 2 plus 3 minus 1. C 3 minus 1. Right, tell me. That is 4C2. Tell me, Devank, Raktim, Memel. Oh, Memel is not there. Devank, Raktim, Onini. Tell me, are you people getting?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Anandit, are you getting? Tell me.
Yes, sir.
So, number of ways to distribute oranges will be how much? What is the number of ways to distribute oranges? Tell me. How many oranges are there? 3 oranges. So, won't it be 3 plus 3 minus 1? C 3 minus 1. That is 5C2. And what is the number of ways to distribute mangoes?
6C2.
6C2. Hence, the total ways will be equal to 3C2 into 4C2 into 6C2. This will be your answer. Okay. Next. Anyone having any doubt, you can ask me. Tell me. Raktim, Anandit, Devang, tell me. Onini, tell me. You people have any doubt? You can ask me now. You don't have a doubt? Let us do another one. Onini, is this some clear?
Yes, sir.
Solve quickly. Okay, I'm solving number one. We need to find out. Now, total, there are how many ice creams? There are 10 varieties, right? Ice creams of each variety are identical. So there are 10 varieties. So number one, let
I've sent it.
I've sent it. Let's see. Okay, Raktim, check your answer again. Yes, only right answer. So let the number of ice creams of first variety. Number of ice creams of first variety will be x1. Number of ice creams of second variety will chosen will be x2. Okay, dot 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 dot. So x1 plus x2 plus up to x10 should be equal to how many ice creams we need to select? How many ice creams we need to select? 4 ice creams. Okay. So the number of ways n plus p minus 1, 4 plus 10 minus 1, c 10 minus 1, which will give us 13c9. Is it clear? Devang, Raktim, Anandit, is it clear?
Yes, yes, sir.
Okay, this was part 2. Part 1. Okay, this is question number 15 and this is 16. Okay, 16, I'm solving part 2. 4 ice creams can be selected such that at least 2 ice creams of same variety are taken.
So I've
Okay,
sent that too.
okay, I'm checking. Oh, no, I think on Nini you are making some mistake. At least 2 ice creams of same variety are taken. Okay, so part 2. So can I say my required answer at least 2 ice creams of same variety means, can I say it is equal to total minus all different? Yes or no? Tell me everyone. Can I say total minus all different? From the total number of cases, if I subtract all different cases, tell me, I'll get the answer. So what is the total number of ways? 13c9 minus, tell me, in how many ways can you select 4 ice creams such that there are 4 different varieties? Tell me.
10C4.
10c4.
So I thought
Is
it
it?
meant like all the varieties you're selecting, there needs to be at least two.
At least 2. Acha, acha, I understood.
Yeah.
No, basically, at least 2 ice creams of same variety. See, it is written. At least 2 ice creams of same variety should be taken. Is it clear?
Okay, so
This will give us how much? 13c9, the value is 750 minus 210. This will give us how much? 505. Okay. 16 should I solve? Tell me. 2 by x plus 5 by y equal to 1 by 3. Okay, pay attention. How to solve this kind of problems. Okay, we need to find out the number of solutions of this equation. Okay, how many solutions are there if xy belongs to natural numbers? So first of all, you simplify this. Number 16. First of all, you simplify this. 2 by x plus 5 by y equal to 1 by 3. This implies 6y plus 5x is equal to xy plus 5x equal to xy. Okay, this implies xy minus 5x minus 6y equal to 0. So from here, I'm going to take x common, y minus 5. From here, I'm going to take minus 6 common. I should get y minus 5. Asha, tell me, how much I
So,
have added on the left hand side?
15x.
What?
So it should be 15x.
Yes, sir.
15x.
15x
Ah,
plus
yes. 15. Anyways, no problem. 15. Asha, tell me, how much I have added on the left hand side? What do you think? How much have I added on the left hand side? Oh, wait a minute. Sorry. It should be minus 15. So 90, I have added 90 on the left hand side. Tell me. Okay. Because I need to factorize this. Tell me. Are you people getting? Or should I explain again? I have added 90 on the left hand side and on the right hand side so that I can factorize the left hand side. Tell me. Is it clear? Devang, Anandit, Amini, Raktim, is it clear?
yes.
Yes, sir.
If you people are having any doubt, you can ask me. Tell me. Raktim, you have any doubt, you can ask me.
No, sir.
Okay. Memel, you have any doubt? Oh no. I mean, Amini, you have any doubt?
No, sir.
Okay. Anandit
No, sir.
and Devang.
No, sir.
Okay. So what will this become? X minus 6 into y minus 15 is equal to 90. Sure. Now it has to be a natural solution. So can you people tell me in how many ways can you write 90 as a product of two numbers? Tell me. In how many ways can you write 90 as a product of two numbers? What is the
6
number
way.
of uh, actually it can be unordered pairs. Why? Because try to understand over here 1 into 90 and 90 into 1 will be two different cases.
Yes, I know that is on the.
Huh?
Yeah, like that only. I'm getting 6.
6. Why? 90 is equal to 2 into 3 square into 5. Right. So what is the number of factors? Number of factors is equal to
15.
1 plus 1 into 2 plus 1 into 1 plus 1, which is equal to 12. So the number of
Correct.
ways, so the number of ways to write 90 as a product as a product of two numbers is equal to 12. So 12 is your answer.
So, but that is ordered pairs, right? 12
Ordered
ordered
pairs.
pairs. But
12
we need
ordered pairs.
unordered pairs.
Why unordered pairs?
So,
You
because
have
you
to
said
take up.
1 into 90 is equal to 90 into 1.
That's what I said. Over here, 1 into 90. That's what I said. 1 into 90 and 90 into 1. They both are different cases.
Okay, so it is different
Are you
case.
getting? Why?
Yes.
Because you see, x minus 6 can be 90, y minus 15 can be 1. X minus 6 can be 1, y minus 15 can be 90. Is it clear? Tell me.
Yes, sir.
Okay. Next, but over here we need to check whether there can exist negative into negative or not. Okay. Now try to understand. If x is something which is less than, I mean, if x minus 6 is something which is greater than 6 on the right hand side. Wait a minute, wait, what I'm saying. If x minus 6 is something which is less than minus 6, okay, like for example, minus 9, okay, then y minus 15 has to be minus 10. Are you people getting? So in this case, you will see that if x is negative, y becomes positive. Are you getting? So over here, both of them cannot be simultaneously negative. I mean, both of them cannot be simultaneously negative. Is it clear to everyone? So you need to check whether they can be negative also or not. Okay, because it is written that xy has to be natural number. Okay. Next, maximizing NCR. Okay. So suppose we are given NCR and we are asked to find out the maximum value of 10CR. What do you think? What should be the maximum value of 10CR? What should be the maximum value of 10CR? What do you think?
NC5.
10C5? Right, tell me. Raktim, Anandit, Devang,
Yes,
are you
sir.
people getting?
Yes.
If you people understood this one, tell me. What is the maximum value of 11CR? Tell me. What do you think? What should be the maximum value?
So 11C5 or 11C6?
11C5 or 11C6? Tell me. Anandit, are you getting? It's not going above your head, right?
No, sir. No, sir.
Okay. So if n is equal to odd, let us generalize this. If n equal to odd, then what is the maximum value of NCR? Tell me. If n is equal to odd, NC n minus 1 by 2 or NC n plus 1 by 2. And if n is even,
NC n/2.
NC n by 2. Okay. Let us do one problem based on this. Exercise number 17. Try. Solve. Only one person has done it. It's an easy problem. Read the question. A man wants to throw as many number of parties as he can out of his 20 friends by calling the same number of people but not the same group. Means he's calling the same number of people but not the same group of people. How many should he call so that the number of parties is maximum? You have to identify how many is calling. Yes, estimate is correct. How many, your answer is correct. And what about Devang and Anandit? What happened? Is it that tough? It's taking so much time. Yes, Anandit, right answer. And Devang,
Sir, is it 20 C10?
20 C10. Why is it taking so long, Devang? Tell me. The number of people he should call should be 10. Devang, what happened?
Yes, sir.
Feeling sleepy?
No, sir.
Okay. 10 and 20 C10 is your answer. Okay. One last thing I should discuss. I'm going to discuss today. Okay, everyone. One last thing. You people are not feeling sleepy, right? Tell me. It's not that late. Great problems. Okay. It's a small topic, everyone. Pay attention. So, you people have been to Kharagpur? Anyone? Tell me. Have you people been to Kharagpur? No one. Okay. So, whenever you visit Kharagpur, I hope everyone gets to visit one day. Okay. So, over there, okay, the paths. Okay, the paths are very symmetric. The roads, the paths are very symmetric like this. Whenever you visit, you will find it. Okay. The paths are very symmetric like this. Okay. Properly designed, properly maintained. Okay. Looks good. So suppose a person is at this point. Okay, that is 0 comma 0. It's an important problem. Pay attention, everyone. Questions do come from here. A person is at over here, 0 comma 0. Okay. And a person wants to reach. The person wants to reach. Oh wait, why did I mark 1 comma 1? 0 comma 0. And okay, the person wants to reach 4 comma 3. Okay, everyone. So what is the shortest path he can take? Either he can move somewhat like this. Right, tell me, everyone. Either he can move somewhat like this. Right. This is the shortest path he can take. Next, another path. Can this be a shortest path? Tell me. Can this be a shortest path? Or he has taken a long route?
A long
What do you
route.
He has taken a long route, right? Unnecessarily, he's coming back. Okay, wasting his time. So this is another way of reaching 4 comma 3. Right, tell me. Raktim, Anandit, Devank.
Yes, sir.
Yes, sir.
Another way to reach is like this. Another way to reach 4 comma 3 is like this. Right. So basically what is happening over here? Pay attention. Okay. I'm telling you, suppose there are roads like grid in a city. Okay. And a person A and a person A wants to travel from 0 comma 0 to 4 comma 5. Okay, he wants to travel from 0 comma 0 to 4 comma 5. Okay, sorry, 4 comma 3. Okay, so one way to travel is, okay, I'm considering that all these paths are of same length. Okay, all these paths are of same length. So he can take four horizontal paths consecutively and three vertical paths consecutively. Right. This is one way to reach 4 comma 3. Yes or no? Tell me.
Yes, sir.
Another way to reach is the blue line. Follow the blue line. So somebody tell me, if you follow the blue line, tell me the order.
VHH, VVHH.
VHH. Next, part 3. The green one is VVVHHHH. Okay. In these three cases, what is happening? Can you people tell me? How many V's you are taking? Tell me.
Three.
Three
Three,
verticals. And how many H you are taking?
Four.
four.
Four. So basically you are arranging, right? You are arranging four horizontals and three verticals. Then you are reaching 4 comma 3. Yes or no? Tell me. You are arranging four horizontals and three verticals. Then you are reaching 4 comma 3. Yes or no?
Yes, sir.
Yes.
Okay. So here we can see, here we can see that in order to reach 4 comma 3, that in order, Anandit, did you understand? Tell me. In order to reach 4 comma 3, what happened? Anandit, are you there?
Yes, sir. Yes, sir. I understood.
We are arranging. Raktim, did you understand?
Yes, sir.
We are arranging four horizontals and three verticals. Right. So therefore the number of ways to travel. Therefore
Seven
the number of
factorial
ways.
into 4 factorial into 3 factorial.
Correct, correct, correct. Number of ways to travel will be 7 factorial divided by 4 factorial into 3 factorial. It's an interesting problem. And this type of problem do come in the exam. That is 7C4. Okay. This is your answer. Tell me, Devank, is it clear?
Yes, sir.
Okay. So everyone, one last problem. Next class will again continue. One last problem. Question number 18. Find the number of ways to reach. Find the number of ways to reach 7 comma 8 from 0 comma 0. via your friend's house 4 comma 5. In between, you must pass through 4 comma 5. Solve. Must pass through 4 comma 5. Solve. Yes. Bhakti, your answer is correct. What about the others? Anini, your answer is correct. Anandit and Devang, should I start? Tell me. Anandit and Devang. Okay, pay attention. First of all, you will reach from 0 comma 0 to 4 comma 5. This is your first way, right? Number of ways to reach 0 comma 0 to 4 comma 5 is how much? 9C4? Right, tell me. Devank and Anandit.
Yes, sir.
The number of ways to reach 7 comma 8 from 4 comma 5. Now you are starting from 4 comma 5. So how many horizontal paths you need? Anyways, whatever number of horizontal paths, what you do is you take the total 7 plus 8, 15. 15 minus 9, 6. So it will be 6. C, 7 minus 4, 3. Are you getting? 7 plus 8, 15. 15 minus 9, 6. So that in total of 6 paths you have to take. Out of 6 paths, it should be 7C, 7 minus 4 or 8 minus 5, whichever you take. Is it clear? Bhaktim, Anandit, Devank or Nini? Tell me.
Yes.
Total number of ways is equal to 9C4 into 6C3. Tell me, Devank and Anandit, is it clear?
Yes, sir.
Anandit, is it clear?
Yes, sir.
Okay. One last part is left, that is dearrangement. Next class, I'll complete dearrangement, okay? And I'll start with a new chapter next class, okay? So I think everyone, we can keep it till now. Next class will again continue, okay? Keep practicing, okay? Very soon, PNC binomial will be test will be taken together, okay? Thank you and good night, everyone.
Thank you, sir.
Yes, I'll send everything.